What's up, guys? This is Ronnie. Welcome back to our channel Total Technology. So today I'm gonna continue the second part of linear algebra. Mostly, like we discussed like basics of linear algebra, why we required linear algebra for machine learning, and I just give some sort of like touch base on vector. We discussed with one sort of example of like images and videos and how to unroll that videos or images in the form of vector, or how to represent one image in the form of vector, and why we need to learn linear algebra and vectors. Those things are covered in our last video, but in today's topics in today's topic I will mostly discuss on like vector, starting from the basics, very basics, like concept of the vector, and gradually I will go into the like some other deep concepts. So mostly in the initial part I'll discuss some sort of theories, and after that I will explain all those theories in the form of like Python, using standard Python libraries like NumPy and other things. So it will be kind of easier for all the viewers to correlate with kind of scientific computing using Python, because ultimately our goal is to develop machine learning algorithms. So if I just do or touch base upon on like theoretical concept or mathematical concept on vector, then that will not make any sense, because ultimately we have to learn how to implement those mathematical concept or linear algebra related concept inside your Python standard libraries, or using Python libraries to develop some sort of like algorithm. So initial part will be theory, and the next part or the second part will be like kind of like implementation of those theories. Okay, so let me just highlight this part with this thing, like again our famous thing, or my this thing. This is part 2. Okay, and today's topic is vector. Okay, okay. So I have created some sort of notes, like for me, just to discuss those things, so that I should not like forget anything. So just to give one short introduction, or like kind of overview of vector. What you discussed in last video, like linear algebra is kind of what do you say, like linear algebra is basically like mathematics for data, and to do some sort of operation on top of your data, you need some sort of component. So vector is one of the most important components. Another component is probably, you can say, matrices. So like with those or these two or many other components are actually like consist of linear algebra. So vector is actually fundamental element of linear algebra. Vectors are mostly 90% cases of the linear algebra will be like in and out will be using vectors to derive, describe, implement our machine learning models. So my goal is that to touch base upon like what is vector, defining a vector. Then we'll gradually do some sort of Python thing like vector arithmetic, then vector dot product, and vector with scalar multiplication. So I'll try to do all those sort of things today, but I'm not sure whether I'll be able to finish those things or not. But if time permits, I'll definitely try to finish those topics. So once this like tutorial is finished, then probably our main objective is to learn some sort of like vector like concept with respect to machine learning or mathematics or linear algebra. So probably when you talk about vector arithmetic, so it will be like kind of like vector addition, subtraction, and multiplication. And when you talk about vector multiplication, we are going to talk about dot product and scalar product, and we will be using NumPy standard libraries for all those things. Okay. So vector can be like from the different like statistical or mathematical point of view. Vector is actually like like what do you say, the list, like list of numbers, and those numbers can be represent as a scalar. in vector algebra we perform like operation on top of those numbers actually. So whatever is vector algebra is vector is actually algebra means vector is a list of numbers and those numbers can be treated as a scalar. So vector algebra is or linear algebra is actually the operation on top of those numbers. And it is uh, like uh, like let me define some sort of like analogy, then it will be easier to understand. Like let's say you have some sort of, let me clear this thing first. Okay, so in mathematical notation, like let's say you have a vector v, okay, and it will be denoted as some scalar quantity v, v1, v1, v2, and v3. So these are the scalar quantity, or as I said, like the list of number. Okay, and this is the vector. This is our vector. So there are many ways we can define vector. Like this is one way of defining vector. Okay. Sometimes we define vector like this, or some of the mathematical books they are define vector with some sort of hat or like this or some hat. There are many ways of denoting this thing. So vector is actually like list of numbers, or numbers means if it's a list of, or like any sort of like defined or undefined quantities can be represented as a number. Like let's say, as we discussed, like let's say you are having some sort of liquid. So liquid property can be represent as a list of numbers. Like list can having some sort of density, smell, color, molecular density, whatever, atomic energy, whatever things, you can represent all this quantities in the form of vector, and after that you can represent this as a vector. So this is kind of analogy we develop just to do some sort of operation in our next part. So this will actually help you. Okay. uh, like one more thing I would like to say, like in most cases, like those are coming from directly from the high school mathematics, those are actually familiar with vector means like this. Like this is xy plane and this is one vector with some sort of direction. But let's say, as I said, like for 2D plane or 3D plane, this is fine. Like this is some x value, this is some y value, some x and y coordinate is there. Okay. But in case of higher dimension, how we are going to represent this line? So that is why we have to do some sort of like develop some sort of analogy. Like all these things are going to define some things, and the number of elements vector is having is known as the dimension of the vector. So let's say you are having like 10,000 or let's say 100 elements inside one vector. Like let's say 1 to up to 100. So you will not be able to describe this element in 100 dimension plane, right? It is impossible to define this thing. So for those things we are having this sort of like numerical what do you say, numerical techniques or numerical concepts or linear algebraic concept to define, to distribute, or to like transform those vector to do some sort of operation. When you talk about operation, we're not going to talk about all the mathematical operation. We're only considering the linear sorry, we are only considering the machine learning related operation where actually which we are going to perform using this sort of vector. Okay. So defining a vector, so we know how to define a vector. So let me just quickly do one more time. Like let's say uh, v is a vector. Sorry. So it can be defined 1, 2, 3. So this is a three-dimensional vector, cos 1, 2, 3 element. So you can again explain this thing like length, breadth, and kind of this thing. This plane you can explain, define this number, let's say here. But if the number become like 4, 5, 7 up to n, then it will be like difficult to define using some sort of plane or some sort of line. So linear algebra is actually very much what do you say, very much important with respect to vector. If you do not know vector, or if you are not clear about the concept like conceptual if you are not having conceptual understanding of the vector, then you will not be able to develop your like base for a linear algebra. Or ultimately, if you're not having any sort of idea, if you're not strong in linear algebra, then there is no point of going for any machine learning thing. So I'm just going very slowly. This part is kind of dry and very much theoretical, but I've just given you 1% of the knowledge of the vector, like how to define this vector. But again, if you can understand this thing, this will be easier for you guys to understand. So I just explained what is vector. Now I am going to now I'll be going to write this thing, like how to define vector, okay, using Python. Okay, so quickly, let me just open my thing. Let's say, let me just pen, then documents, then linear algebra. I think, let me just, okay. So for any sort of linear algebraic or mathematical or scientific computing for Python, hands down the best library is NumPy. I have already completed one tutorial on NumPy. Just go to our channel and search with NumPy. You will get the full tutorial on NumPy. That was, I think, a three hours video. So you will get much like in-depth knowledge about NumPy. So let's say we're defining one vector using Python. So let's say A is a vector or V is a vector. V is a vector, np dot array, and 1, 2, let's say 3. So A is a vector. So in this way we can define vector in NumPy. Okay, I think this is clear now. Okay, hope this is clear. Okay, so now the next part is vector like addition, like how to add to vector. So let me open this thing here, like okay, so let's say I'm having two vector A, it is two element 1 2, and one vector V is having two element 2 2. So vector addition is element wise, like means this will be added with this and this will be added with this, so the resultant vector will be 3 4. Okay, so this is kind of vector addition. Okay, so one more thing, like I would like to say, I'm just thinking, like shall I do it using NumPy, or like this is fine? No, I think I should do it using NumPy, then it will be easier for you guys to understand. Okay, so this is clear, right? Vector addition is element wise. Okay, so if I just define one vector like v, and let's give it another name like this, let's say c equals to v plus b. So I'm just going to change this thing, like 2 2 3, like it will be like 3 4 6. Okay, let's print c, then it will be 3 4 6. So see, it is 3 4 6. So in this way we can do some sort of vector addition, like using NumPy or Python. Okay, so I'm doing the conceptual part and I'm just doing the numerical like computing part using Python as well. So like you guys can easily like understand the concept. So it is not like that I'm just doing the theory today and next week I'll do the numerical part. So, and I think if I can do it, but again it is not going to make any sense. Okay, so the next thing is vector subtraction. Now vector subtraction is also the same way, like same way means like what do you say, like it will be also kind of element wise, like the element will be subtracted. Okay, so the same way we can be like can be done. Let's say when you say same way, like let me just quickly give you one example about that. Let's say a is a vector like 2 2, and b is a vector 1 2. So the resultant vector c equals to a minus b equals to like a minus b is become 1 0. Okay, and if you do b minus a, it will be minus 1 0. So we'll see the concept over here. It is also element wise. Okay, okay, let me just change this vector a bit. 1 2, and just make it like no, let's do it like 2 2 and 1 2. So this like this, so it will be like 1 0 1 0. And now if I do it like the opposite, like b minus b, so it will be minus 1 0 c minus 1 0. So this is also element wise, right? Okay, well, I think we're doing some sort of good progress. I have something for you guys, but I'm not sure whether I can do it or not. Let me just try something unique. Okay, one of my friend is working for some of his research project, and he gave me one like script like this is purely on Python. I have gone through the script. This is really nice. So it is actually help you to understand this graphical concept using this sort of things. Okay, so I'll explain you what I'm going to perform now. Okay, like mm, I think I think that there is a okay, sorry, I think I did a mistake. This is going to be plot underscore helper. I'll give you the script. I'll explain you what is happening actually over here. uh, Plot vector. Okay, so let's define two vector. Let's say 1 2 and b equals to like 2 2. So I have a vector 1 2, and it is having like kind of like 2 2. Okay, 1 2 and 2 2. So if I just I'm just thinking like how to draw this thing. mm, let's define one vector 1 2 and another vector with like 2 2. C equals to think now I would like to draw this vector. Plot vector like a comma b comma a plus b. Actually this is one method like let me just open here. search this thing. Okay, this one. So it takes vector and tails, and it is a plot. So vector means vector and I think okay. So guys, I think there are some mistakes like as per the library documentation, but let me explain this thing. So we have created the vector the slightly different way, and we have created this vector this way, but don't follow this this syntaxes, because this is just for representation. So one vector starts with 1 2, you see this one, and one vector starts with like 2 2, like 2 2. Okay, and this is the resultant vector, and all these vectors are having like a basis from 0. Nothing provided means the base is 0. So like there is actually two vector, like this is 1 2 and this is 2 2, but I'm not sure, like this vector start from 0 and from 2 2 means here. Okay, let me define some sort of tail for this one, then it will be kind of um, what do you say, like like 0 0. I'm just giving some sort of tail, then it will be easier to understand. Okay, uh, I'm just thinking what shall I give in the form of tail, like I think I can give it to like 0 0 is fine, no problem. Okay. Okay, so let me just define one thing. See, this 1 2 means this is one vector and this is one vector. So addition means the magnitude will be the length. So if you just put this vector over here, so the length become from here to here. So this is the thing. So we don't need anything with respect to tail. So if you subtract this thing, like this thing, actually nothing is changing for subtraction. I'm not sure why. Or let me just make it like b minus a. Okay, plot underscore vector. I think vector. So this is the resultant vector. If you see, like like it became b became minus like minus 1, like b minus s mean like 1. Okay, means here let's say, and it becomes 0, like in this direction actually 1, so that is why it is here actually. So we can do something similar, like let's say let's take it like 4. Okay, and this, and then it will be like here 3. So it came until here, until this position, if you see. And if I just make it like b plus a, and let's say minus 4, so it will be in a reverse direction now. See, it is now in the reverse direction. Okay, so you guys understand now the concept of this thing. So this is one vector, like as you mentioned, like 1 2, this is one vector, this is minus 4, this is minus 4 to one vector, and this is the resultant vector b plus a. So it is going like until this direction for -3, and in this direction for +4, like this. So this is actually very much useful for all the physics student. Those are actually, or some mechanical students, for them as well. Those are actually working as well with thermodynamics and all, for just to understand some heat flow and heat kind of a thing. I'm not going to in that details, but for our case this is not going to be like that much important, because we'll be completely dealing with the like mathematical analogy. We're not going to represent anything. Definitely will represent, but not with respect to vector. Okay, so guys, just skip this part. I kind of messed up the whole video for this library, but I just wanted you guys to show you this, the amazing thing of this Python thing. This library is really amazing, but actually it is not actually published in the form of library. I just got the piece of code is having with me. So probably within 2 or 3 months they are going to publish this via PyPy. Okay, but right now I'm having this code. I'll upload this code in the GitHub so you guys can use these things. It is not my code. I haven't written this code. This is one of my friend gave this to me. Okay, so we are in this section, like we saw like how to represent, but this is not going to be like impacted for our case. I just wanted to show you guys something is available. That's what I did. So we have seen like addition, we see it like subtraction. So the next part will be I'm just thinking the next part will be probably let's say I think multiplication or vector dot product is the next part. Yes, I think multiplication is the next part. So probably we can do like I'm just thinking like mm, I'm just thinking what could be the right thing, like I think like in vector there is two type of like multiplication. One is called Hadamard multiplication, one is called like dot product. Hadamard is also vector, like when you are like multiplying two vector together, it is also called Hadamard multiplication. Also we are doing like vector multiplication with vector to vector, also called that is also like possible with dot product. So there are two types of multiplication. Hadamard means like element wise multiplication, just like addition or like subtraction, but dot product is completely different. Like here I'll be going to show you what is the dot product. So guys, let me just open this thing, like this thing. Okay, like this thing is going to be like dot product. Let's say like dot product, let's say okay, let's say this is one vector, like 1 2, and this is v1 and this is v2. This is 2 4. So v1 dot v2 is going to be 1 2 and 2 4. Okay, so the dot product means like um, like uh, the dot product is like I'm just thinking like how to represent this thing with respect to Python actually, because if I do it then it will be kind of whether I can do it or not, I'm not sure, but let me just thinking. Mm, just thinking. How to do that? Like, let's say some sort of like, actually, I need some sort of notation, or else it will be difficult. Let's say A1, A2, and this is called B1, B2. So this is going to be A1, B1 plus A2, B2. So this is actually the dot product. Okay guys, so there will be only scalar quantity one. So dot product gives scalar quantity, but Hadamard product or the matrix like element wise multiplication will give the vector, resultant vector. Okay guys, so let's try this thing actually. Well then, np dot a comma b, say a is not defined, let's say v 6. But if you just do uh, v b, it will be element wise, see, 2 to 4. So this is called dot product, this is called Hadamard product. Like, let me just quickly, why this is required is some sort of matrix, like Hadamard product, like in vector. Okay, so this is element wise. And if you like to do some sort of scalar, like let 3 into, let's say, v, this is also going to be vector. Okay, this is also element wise. 3 will be multiplied with the first element, 3 also will be multiplied with the only dot product gives scalar quantity, like only number, but remaining all other things will be giving the vector. Okay, so we have covered like multiplication with vector, multiplication vector to vector as a dot product, multiplication vector with scalar. And we have seen like a matrix, sorry, not matrix, we have seen vector addition, we have also seen vector subtraction. Okay, so what else is required? I'm just thinking. uh, mm, okay, one more thing, like if you would like to do some sort of, like, just say v plus 3, this is vector with a scalar addition. This is also going to be kind of like vector, let's say v minus 3. This is also going to be written this. Okay, let's divide like vector by vector. If you division, like vector division, we haven't touched upon this thing, so we'll be going to see that now. Okay, I think vector division is also kind of like what do you say, like element wise. If you just quickly, let's say v by b, see, this is element wise. Okay, so v by 3 will be also element wise, but it is going to be also written one vector. See, so only dot product gives scalar quantity, like only number, but remaining apart from dot product, everything gives as like vector. Okay, so please remember this thing. Like we have seen vector to vector addition, we have seen vector to scalar addition, we have seen vector to vector subtraction. At the top, we have seen vector to scalar subtraction, we have seen vector to vector subdivision, we have seen vector to scalar division, we have seen vector to vector addition, Hadamard product here, and we have seen vector to vector dot product. Okay, so I think this is this is fine for today. Probably we can start in the next video, like in some other operation with vector, kind of like matrix. I think vector is done. We can easily start with the matrix. Let me just check what is still pending with respect to vector. Let me just quickly open my notes. Yes, I think vector is done almost. Yes, not almost. It is actually completed. Yes, I think from the next tutorial we can start with what do you say, like this sort of things, like vector norm, like L1 vector, L2 vector, and max vector on vector norm. There is something called vector norm. Okay, so in the next tutorial we'll see what is vector norm, and from the next tutorial, like after like the next tutorial means from third tutorial, we'll be only going to touch upon the vector norms, and from the fourth tutorial we'll be going to start vector algebra and matrix algebra. So I will start with the basic like fundamental concept of matrix, and after that we'll go dig deep into like the arithmetical operation with vector and matrices. So when we'll do the matrix operation, all the concept whatever we learned till now regarding or related to vector will be actually helping us to develop those like intuition or those like methods. So that time it will be easy. So guys, please kindly do some sort of homework, try to do some sort of practice. Like this is a very small tutorial I'm just giving for today, but if you see like we have completed too many things. Like if we just open this thing, like let me just maximize this notepad. Like we have seen like we have seen vector addition, we have seen vector to scalar addition, we have seen vector subtraction, we have seen vector to scalar subtraction. Okay, we have like with respect to addition and subtraction, this many things we have covered. And for like product, we have seen like dot product, we have seen Hadamard product, sorry for my bad handwriting, and we have seen scalar multiplication. Okay, and as well the division. I think 7 or 8 or different topics we have covered already. Okay, guys. So I'm not sure like if anything is still pending. I'm just thinking. Just give me 1 second. Okay, I think in the code base like. Let me just open this code base, guys. This is very simple thing. Like it will take only 5 minutes. If someone is going to spend only 5 minutes, they will able to understand what is the vector thing. So with respect to vector arithmetic, preliminary vector arithmetic, we only require these things like addition, subtraction, multiplication, division. When we talk about addition, we have to talk about like vector addition and addition with scalar, vector subtraction with scalar, multiplication with vector to vector. But there are two different product like Hadamard and dot product. Hadamard only dot product gives with respect to all operation only gives scalar quantity, but apart from like a dot product, all operation will give vector. We have seen vector division, vector to vector division, and vector to like scalar division we have seen. And also you have seen normal scalar multiplication. So guys, I think this is quite lots of info, and I'd like to say sorry guys, in the mid of the video I messed up the some time with just to showcase some library, but again it was like I did it intentionally just to give you guys some sort of intuition like how it actually works. So this is actually when you talk about length, this is actually adding this coordinates in the normal geometric plane. Also you guys see like when you do this addition. So let's say this is one vector, and after that if you just go negative direction from here, and if you just add this vector on top of this thing, then it will actually having length of this one only. So to like develop this sort of intuition, I just did I just gave this sort of like example, guys. So if you would like to learn more about vector, then I'll highly recommend you guys to go and to YouTube and watch Khan Academy's videos and One Blue Three Brown videos. They are actually doing this sort of intuition in a much like detail and much easier way. I think Khan Academy is the best thing to learn vector. I actually developed my intuition for vectors and linear algebra from their tutorial. So this is actually bible for that channel is actually bible for all like vector videos. So if you have some time you can go through it, but if you're not having time, fine, fair enough, just watch my tutorial. It is kind of shortcut, but again when I'm talking about shortcut, it is like with all the related stuff with respect to machine learning only, and those Khan Academy and One Blue Three Brown are actually core mathematics. So Anyways, learning is always fun if you are having some sort of time, and if you are interested to learn more about vectors, then you can go and invest your time on vector. There is nothing wrong of learning something. Okay guys, I hope you guys are enjoying my video. I'm not sure how I'm doing. If you think this video is actually should be presented in a more better or productive way, just please do let me know. I'm just doing it kind of like whatever I like learned or whatever I studied, the way I am teaching, this is actually same. Whatever I learned a few months or few years ago, in the same way I'm just actually teaching. This is my way of learning, like by sketching something, after reading something, and after that have to put something in the form of like programming and all. So we did some sort of conceptual, like develop some sort of conceptual thing, and after just directly we just put this thing over here. So I think this is the right way of doing this thing. So once you completed this video or completed this series, then you will be actually ready for the future machine learning tutorial, because you will be that time having knowledge of theoretical part from learning linear algebra, and as well as you will be having like implementation knowledge of linear algebra, how to implement all those theoretical concepts. So you do not have to waste much time. So that's all guys, that's all for today. Hope to see you in the next video. Till then, take care, goodbye, and don't forget to subscribe our channel. And if you have some feedback or comment, please let us know. Okay, happy weekend. Hope to see you in the next video, probably tomorrow. Till then, take care, goodbye.